Now, we haven't learned this yet, but if you can't tell, my pattern is put something on there the day we're going to learn it to see if they can just logically figure it out. And I don't usually do it unless there's a way you can logic your way through it. Blake, how do you think we set it up? Hold on. I forgot to turn on my board, but hold on to that thought. It sounded like it was really good. All right, say it again. That'll work. And what do you get when you cross multiply? Well, then you divide by 15. 19.2 is correct. What's another way you could set this up? He went top to bottom, top to bottom. What's another way you could do it? You could just flip them, but we already learned. Remember that proportions day where we learned you can flip them? We already knew you could do that. But what's another pairing? Instead of putting the 60... Oh, you're overthinking it. Instead of using these pairs, what's another way you could match them up? That's right. You could put 16 and X together and 15 and 18 together. I'll repeat again. We're making a whole day out of these kinds of proportions. Good. Yes. Yes. Well, if you remember, the day that we did proportion, we said you could put the numerators together and the denominators together, which is what we did. These are harder to mess up than they are to get right. They really are. And we're going to spend an entire day on these because I teach ACT prep and I've never seen a math ACT without at least 2 of these kinds of problems on there. If you ever see 3 numbers on a random picture and it asks you for a missing one, it'll pretty much always be your proportion. Proportion, 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 proportion. Yeah. Good question. They put right angles there because of a theorem we're going to talk about. Technically speaking, you can only do this if these lines are parallel. These right angles, well, by use of one of 2 theorems. We had a theorem, I don't remember what number it was, that said if 2 lines or more are perpendicular to the same line, then they're all parallel. So that was a way to conclude that. Or you could have used the corresponding angles converse that said if corresponding angles are congruent, then the lines are parallel. Technically, the theorem today says if the lines are parallel, you can do that, which they will be if they ever give it to you. Okay, good question. 6.6, proportionality theorem. Proportionality theorem.
So by using context clues, I can conclude that it'll never be right.
What is it? What is it?
Oh yeah. No, my student worker.
My student worker does my grade. That's why I doesn't put their numbers underneath. But this was the only one of these he found. I guess I told him not to turn in or something. So he wrote it, and he didn't know what assignment to do. Yeah, it wasn't supposed to be told, but he literally didn't know what it was. If you walked over it. Okay. Yes, eventually. And this is the class they're probably going to teach the most.
What? They're going to teach us?
Yes. Aww. Geometry. All right. Yes. First proportionality theorem of the day. If you want to draw the picture and make something about it, or if you want to write it verbatim, it's completely up to you. If a line to one side of a triangle intersects the 2 sides, then it divides the 2 sides proportionally. Now remember, Elon, you have a pause function you're welcome to use at any time. That's right. Only a few minutes at most. It has to be a productive pause. I don't have to pause on you to finish their conversation. I will overrule your pause. So while you're writing, I was thinking last night, I'm somebody who gets all my energy from a good amount of sleep. I get 8 hours a night. Anybody else get 8 hours a night? Wow. Some people just need their sleep. I hear you. Except I'm gonna have a child next year when I'm teaching, and it's like I'm not gonna get that much sleep. I'm not gonna be very good teaching. You're productive. What are you saying? 10 hours, 8 hours, 10 minutes every day? What? Well, I'm just not going to have this much sleep next year. I'm already depressed about it. Okay, so here's what a problem like this will here's what a problem like this will look like. 6, 4, I'm making this up, 2x. 3 numbers, you're missing 1. You just set them up as a proportion. You don't even have to do it like this. You could do it either of the 2 ways we did it in the DOM. This is just an example. We're not even going to solve it. But that's the point of this theorem. If you have 2 parallel lines, one of them going through a triangle, then you can set up a proportion of the pieces. That's the whole point of the theorem. It's the whole point of the day. Now, the next thing I'm going to put on the board, you do not have to write down, but I just want to talk about it with you. This is technically a different theorem. It's the converse. Now, you won't have a proof about this, so you don't have to write it down. But today, there will be a few questions that it'll give you all 4 pieces. And you're going to think, what's the point of this? The point of this is the converse. You can show that the lines are parallel by showing that the pieces are proportional. For instance, let's say this was 8, 10, 4, and 5. I realize these are not actual measures, but if they were. Are the pieces proportional? 8 over 4 equals 10 over 5, so you could conclude that the lines are parallel. But what if this was like a 6? Does 8 over 4 equal 10 over 6? No. Then they are not parallel. That's the point of the converse theorem. And here's the thing. You'll know basically what to do without even knowing which theorem to use. Today, if you have one with all 4 pieces there, you're just trying to show that they're proportional. Don't think, hey, I don't have to do anything to this one. He accidentally gave me the answer. If it gives you all 4, you have to check the proportion. That's what you have to do. And then it'll be a yes or no question. Questions? Good. Let's look at one. Are we missing a piece? Then that's what we're solving for. I didn't even bother putting the directions up here. If you're missing a piece, that's what you're solving for. Elijah, how do you think you want to set this one up? That'll work. Ooh, you had it right the first time. Very good. Why do you think it matters? Notice you went top to bottom, so that's the way you have to go the second time again. 8 over x. If you mix those up, if you go top to bottom, bottom to top, your proportion's not going to work out the same. You have to go the same way. And you could have gone 8 to 12, but then you would have had to go x to 9. You couldn't go 8 to 12 and 9 to x. Then you would have gone left to right, right to left. It has to be consistent, whichever way you go. Does that make sense? All right, cross multiply. 8 times 9. Ooh, very nice. Equals 12x. Divide by 12. That's what Justin got. And you solved it. Every problem today that's missing a piece will just be a proportion. Set it up. They are literally harder to mess up than they are to get right. All you have to do is be consistent with the way you do it. Questions? Now, this is a very straightforward one. Sometimes the piece you're missing, well, actually, never mind. We'll get to that in a second. Exactly. If they give you all 4, you have to show the lines are parallel by setting up your proportion. So, Clay, how do you think you want to set this one up? Ooh, that's the only pairing you can't do. There you go. Yes. Equals what? No, what's the other pair? There you go. Now you need to show that they are the same. There are 2 ways to do it. You could divide them. 18 over 27 is 2/3. 16 over 24 is 2/3. Yay! Or, what else can you do?
Multiply.
Cross multiply. Does this equal this? Oops. If they equal each other, then the proportion is true. So, you could either reduce Or you could cross multiply. If they're the same, yay, the lines are parallel. So this one would be yes, they are parallel. And if it hadn't worked, you'd put no, they are not parallel. Questions. You are going to have at least one like that today. I think 2 or 3 actually. Just plug in the numbers, see if they're parallel. All right. Next theorem. This is actually the one you did in the DOM without even knowing it. If 3 parallel lines, which is why they gave us the right angles, intersect 2 transversals, then the transversals, then they divide the transversals proportionally. Which is exactly what we did in the DOM. Theorem 6.6. If they give you 3 or more lines that cut through 2 common transversals, then they divide them proportionally. The key here is that they're parallel. So once again, even though there is no converse to this theorem, if they were to give you every piece, what do you think you'd be doing other than like somebody other than like? If they give you every piece, what do you think they'll be asking you to find? Yeah, are they proportional, and therefore are they what? Are the lines what? Parallel. Yeah. If they give you every piece, you're just looking to see if they're parallel. Would anybody like me to pause? Okay. Okay, Jensen, how would you set this one up? Yes. Okay. Very good. Where does this look familiar from?
DOM.
This is very good, but you got it correct. This is the DOM. I wanted to see if it still looked the same, and it is, and it will still be 19.2. Very good. New theorem, last one of the day. Guys, if you have a triangle and bisect one of the angles with a ray, then once again, same thing as today, they're proportional. Proportional. That's what we're doing. That was the only thing I ever made all state in high school was singing. But then football took my voice. Well, yes, I did. And I was always yelling, and I would lose it. We had an all-state concert one day, and I'd had a football game the night before, and I couldn't talk at all. And my choir instructor was so ticked. So I just had to act like, no. I was a quarterback. I was always yelling at people. Yeah, that's where my shoulder gave out. Sad day. I wasn't very good though. No. The opposing team's defensive lineman, because our line was terrible. Elijah would have been about our average size O lineman, and that's a compliment to you because he's a physically fit young man. We had no girth on our O line at all. It was bad. They were like a sieve. And our coach was like, "Let's run wishbone." I'm like, "We don't have any offensive line." I was our leading rusher one game with -4 yards. True story. Our coach was a moron. Hey, this is going on YouTube. Bob Nelson, if you're anywhere in the world, you were a moron of a coach. It's going on YouTube. Might as well tell him. Yeah, dude was an idiot. Does anybody need me to pause on this slide? Okay. Once again, it's just going to be setting up proportions, like a D1. Now, Yasmin, how would you set this one up? That'll work. Gotta be, there you go. Gotta be consistent. If you go long side to short side, then you gotta go long side to short side again. Very good. What do you get? Very good. 3 times 4.5 is 3.1 times 1.5 is 4.5. 4.5 times z, divide both sides by 4.5. Z equals 1. Very good. That's a z. It's not, okay? It's not. Okay. Now, questions about what every single one of these theorems is trying to get you to do. Excellent. Now, These have all been very straightforward. What if the piece they gives you, what if they don't just give you the nice 3 convenient pieces, like this one? Notice, it's broken into 4 pieces, but they didn't give you the 4 pieces you could use. You still have to solve for x. Guys, you can't just use the 15. It is not one of our 4 main pieces. Do you see that? But let me ask you this, Jensen. If x was 5 and the whole side is 15, how could I find this piece? If the whole side is 15 and this piece was 5, how could I find what this was? Tag Justin in. I think he wants it. Justin. You could just subtract it. Very good. If this was 5, that would be 10. If this was 6, that would be 9. They have to add to 15. So, if one of the pieces is x, here's the kind of thing you're going to need to do today if you have one like this. You're going to need to label the other piece 15 minus x. That way, no matter what x is, the other piece is just 15 minus that. Now, once you have it set up like that, the exact same as the last few. Trip, how would you set this up now? That will work. Then you have to cross multiply again. 7x equals 13 times 15, somebody. What? 13 times 15? 195. Minus 13x. Remember, we have to multiply the 13 times the 15 and the x. Which would give you what? Divide by 20. And x equals 9.75. Very good. You're going to have to do that on at least a few problems today. You have to use the subtraction property to figure out. It'll always be the total minus whatever the piece it gives you. Sometimes it'll even do more than that. It'll say, hey, this piece is 21. Well, guess how we're going to find this piece? Well, this is a bad example because it's greater than 15. Yeah, you just, if it gives you the number, then you can find the number just by subtracting. Let's find one like that. I think I've got one like that set out. Do I need to leave it on this slide? Okay. I don't know. Okay. Now, Brandon. If this piece is x, going just by the last example, if this piece is x, what can I label this piece? You're the man. 33 minus x. Very good. Now, Cameron, how am I going to set this up? That'll work. Then what? X. We're not using this anymore. We just needed that to come up with this. On the top or the bottom. It matters. Very good. You know why it's the bottom? It's okay if you say no. Alright, look. You went left to right, right? Left, right. So you have to go left, right again. You just have to be consistent. See? You see? Alright. So, how are we going to solve this? Cross multiply. 54 times x. 45 times 33. I'm not even going to try. Somebody tell me. Thank you. Minus 45x. How do I solve now? I do add 45x. I'm only human! 99x equals 1,485. Divide by 99. Who can tell me? 'Tis 15. 'Tis indeed. 15? Okay. This is what we're doing. There's no other little curveballs. This is it. Are there questions? Okay. And as has become our norm, I'll be passing out a worksheet to you stapled to the back. I want them stapled to el backo.